So in this video, we're going to look at an example of using the shell method to find a volume of revolution. In the case where using the disk method is either hard or maybe essentially almost impossible. So the example says attempt to use the disk method to find the volume of the solid of revolution formed by revolving the region bounded by y equals x cubed plus x plus 1, y equal to 1, and x equal to 1 about the line x equal to 2. So here's the line x equal to 2 right here. We want to revolve around that line. And the bounded region is right here. This is y equal to 1, x equal to 1, and here's the cubic function right here. So we want to rotate this region about this line. And what I want to recognize is if I'm rotating this region about this line, this region in here is missing, which means from the disk method homework assignment, this would be a washer method problem where you have to subtract off the missing volume. So the setup for this using the previous homework, the disk method, would be to say, hey, to calculate that volume, I'm going to need to integrate, and it's going to be pi times, I'm going to have a difference between a large radius and a small radius, and then times either a dy or a dx. And the key is, in this case, because we're revolving around this line, the disk method would say establish your inner and outer radii. So my inner radius is going to be, right here's my representative rectangle for that inner radius, and here is that representative rectangle for the outer radius. So we would need to describe both of our radii. And what I want to recognize is that if I have an xy coordinate right here, this larger or outer radius is just going to be 2, x equal to 2. But then I need to subtract off the x coordinate. So this distance right here is going to be the distance 2 minus whatever the x coordinate is. So my outer radius is going to wind up being 2 minus x squared. Remember, it needs to be pi r squared because we're summing cross-sectional areas of circles. And then my inner radius, which I would need to subtract off, is just going to be 2 minus this line here is x equal 1. So I'd get 2 minus 1 quantity squared. And then when I look at my representative rectangles, I recognize that I have dy slices. These are dy slices, so I have to integrate with respect to y. So I would have to run my integral from y equal 1 to y equal 3 along the y-axis. We're running our integrals this way with dy slices, so from 1 to 3. And because I have dy slices, I have to be able to describe my x-coordinate here as a function of y. I need x as a function of y because I'm integrating with respect to y. So I have to come up to my function that relates x and y equals x cubed plus x plus 1, and I would need to solve this for x. So we started by subtracting 1, we get x cubed plus x, and then if we stare at this for a while, we're going to recognize that this is really, really, really hard, probably impossible for the typical mathematics user. So what we've run into is a disk method formula that we can set up. I can plug the x in here, but I can't get the x as a function of y because I can't solve this cubic polynomial for x easily. So the same question, but now, hey, find that volume of revolution. Let's use the shell method instead. So the shell method, we still have the same bounded region. But if we're using the shell method, we're going to create open cylinders when we rotate. So our representative rectangles will need to be parallel to the axis of revolution. So we construct our representative rectangle this way, and we're going to sweep that out and rotate the representative rectangle in a circle about the line x equal to 2. And when I look at this right away, what I notice is I have a dx slice. So if I start to set up my integral, we know it's going to be 2 pi times the radius, 2 pi times the radius of revolution. So grab the point here and stretch out to here. There's my radius of revolution. How do I calculate that distance? Well, that distance, if there's an x coordinate here, right? We have an xy coordinate here. To get the distance, it's going to be 2, because we're at the line x equal 2 minus x. In fact, that comes out to be the same radius of revolution we calculated on the previous slide. The radius of revolution isn't going to change in this case, so we're going to get 2 minus x, 2 pi r. This is a circumference, so we're not squaring it. 2 pi times radius to get the circumference of revolution. And then what we need to do is find this height as a function of x. But notice the height is going to be the difference between the y's. If this is an x2, y2, sorry, x, y2 sitting here, and right here we have x, y1, well, y is always equal to 1 there, so you're just going to have a 1. So to get the height, you'd actually take y minus 1. Say, hey, take the y minus 1 to get the distance from here to here, where y, in this case, is representing the function. That's creating this upper bound. And then our slices are dx slices. And so the issue is the same as we had before. We can't just have a, before in the previous slide we had x with dy slices, which meant we needed x as a function of y. Here I have y, but I have dx slices, which means I need to know y as a function of x, but I do. Y is equal to x cubed plus x plus 1. So dx slices, I'm going to be integrating from 0 to 1. 0 to 1 gets everything with dx slices. So it's going to be 2 pi times the integral from 0 to 1, 2 minus x times y, but y as a function of x is just x cubed plus x plus 1, and then it'll be minus the 1. So we're gonna wind up getting just x cubed plus x right there, dx. And then to integrate that, we probably are going to want to multiply this out first. So 2 times x cubed plus 2 times x. My x cubed is kind of looking like a 0, so plus 2 times x minus x to the 4th power minus x squared dx, and now we just integrate. This is 2 pi times, what are we going to get there? That's going to be an x to the 4th, and that's going to be 1/2 x to the 4th plus x squared minus 1/5 x to the 5th minus 1/3 x cubed from 0 to 1. And now if we want to notice, if we plug in the lower bound of integration, the 0, it just kills everything inside of here by a bunch of multiplications by 0. So we only need to worry about plugging in the upper bound of integration. In each case, we'll be raising the 1 to a power, so we'll just get 1. So we wind up just getting 2 pi times, it'll be 1/2 times 1 plus 1 squared is just 1 minus 1/5 times 1 minus 1/3 times 1. And then it's just a matter of simplifying. 2 pi times some stuff over what's the common denominator? The common denominator is a 15. And so we'll need to multiply this will get this, when we get the common denominator, will give us a 15. This will give us a, sorry, the common denominator is going to be a 30. 5 times 3 is 15 times 2 is a 30. So this will give us a 15. This will give us a plus 30 minus, we'll need to multiply by 6 over 6, so we'll get minus 6. Minus, this will need to be multiplied by 10 over 10, so we'll get minus a 10. And then we just need to simplify things. We get 45, we get 2. This will go in there like that. So bringing this up here to simplify, we get a pi over 15 times. We get 15 minus 10 is 5. 5 minus 6 is negative 1. 30 minus 1 is 29. So we get a 29 pi over 15 for our volume. So this is one where using the disk method, we're able to do it. Using the shell method, we're able to actually get the volume. But using the disk method, we run into that problem where we can't solve for x. So in general, that's going to be, like I mentioned in the previous video, that's going to be the big idea. Disk method, shell method. Sometimes both methods work. Sometimes both methods are equally easy. Shell method, disk method, sometimes both methods work, but one method is superior to the other given the context of the problem, usually depending on which axis you're rotating about. And then 3, the other situation that can show up is the disk method works and the shell method doesn't, or the shell method works and the disk method doesn't. Or you get one, and then sometimes you can run into, you can set both integrals up and both of them are going to be hard to integrate. So anything can happen. The key is, if you're not being told with which method to use, if you need to find the volume of revolution and you're not told which method to use, you're really trying to think about which of the methods is going to be preferable.